Okay, so this problem says projectile is launched at an angle of 30 degrees. Okay, when they say a projectile, what does that mean? Yeah, it's an object traveling only under the influence of gravity. Okay? And lands 20 seconds later at the same height as it was launched. Okay. What is the initial speed of the projectile? So and 20 seconds later. Okay. So what they're asking you is for the initial speed. Yeah. So here's a couple of things, the initial y location and the final y location are the same. Okay. And the speed is what they want, what they're asking you, and that's one unknown. So let's look at the y motion. Okay. And again, when you're doing this kind of stuff, draw your axis x, y, v naught. That's the initial velocity is v naught cosine 30i plus v naught sine 30j. What is the acceleration vector? What is this vector in component form?
0I plus minus 9.8 j.
Very good. Okay. So let's look at the y motion. Y minus y naught equal to v naught yt plus 1/2 ayt squared. Y minus y naught, this is 0. Yeah. And the y component of the velocity is this guy, v naught sine 30. Ay is minus g. Yeah. And so this equation has two solutions. Okay, t equal to 0 is a solution. At t equal to 0 it was there. And the other solution is v naught sine. No, well, v naught is what we're solving for t equal to 20. Okay. So equal to 0. V naught is gt over 2 sine 30. Yeah. 9.8. 20 seconds. It's 98,196. Okay, so the initial speed is about 200 meters per second. 10 meters per second is roughly 25 miles an hour. Okay, so that's 20 times, so 500 miles an hour. Okay, so this projectile is launched at 500 miles an hour, and you see that makes sense. It lands 20 seconds later. Okay, so this is okay. All right, what is the maximum altitude it reaches? So maximum altitude is, they're asking you for this height h. Okay? And you can look up formula H is V naught sine theta square or 2g. Okay. We just solve for the speed, so it's 196 meters per second sine 30 square divided by 2 times 9.8 meters per second square. Okay. That's 490 meters, so which is about half a kilometer. It's about 10 times the tallest building on the beach. Yeah, that height. What is its range? Range is the horizontal distance it travels when it comes back to the same vertical position. And you can look at the range formula. Range is okay, let me confirm that range formula. Okay, so there's the range formula. (196) sine 60 Okay, so 3.4 kilometers, which is a little over 2 miles. 1.6 kilometers is a mile. Yeah. So 2 miles is roughly from here to the speedway. Yeah. So the projectile goes as high as 10 times the tallest building here and goes and lands in the speedway. Okay, so they ask you calculate the displacement from the point of launch to the position on its trajectory at 15 seconds. So here it is at 20 seconds. So at 15 seconds, it's somewhere here. And what they want you to find is its x and y coordinate. Okay? So we are assuming it's starting at the origin. Okay? And so you're finding its final x and y position at 15 seconds. So let's look at the x motion first. Let's x minus x naught equal to v naught x t plus 1/2 ax t squared. X component of the acceleration is 0. We start off at the origin. Okay, so x is 196 cosine 30. And what is the time? 15 seconds. So you're finding its location at 15 seconds. Okay. y location is y minus y naught. Again, this guy is 0. Okay, so you can write the answer either way. Okay, so that's the final position vector. And remember, the maximum height was 500 meters, so this has got to be less than that. Okay, that's less than that. And the range was 3,400 meters, so that x position had to be less than that. Yeah. Yep.
Could you go back to the calculation for x?
Which one?
For x.
All right, so let me, you'll see many problems like this. What you want to do is set up your axes, your initial position, so initial position is 0, 0. Your velocity, you want to write your velocity in component form. You want to write your acceleration in component form. And then look at the x motion and the y motion independently. Okay. Whenever you need timing information, you generally get it from the y component of the motion. Okay? All right. So here's an interesting problem. Again, a projectile. So air resistance is negligible. The only force acting on the object is the force of gravity. Very good. Okay. It's shot at a hill. So this projectile is shot at this hill, the base of which is 300 meters away. The projectile is shot at 60 degrees, the launch angle, about the horizontal with an initial speed of 75 meters per second. The hill can be approximated by a plane sloped at 20 degrees, so to the horizontal, relative to the coordinate system shown in the, relative to this coordinate system, the equation of this straight line is y is tan 20, which is the slope. This is in the slope intercept form. Slope x, and that is the y-intercept. So if you extend this line, it would intersect at minus 109 meters. Okay? So it's in the slope intercept. Where on the hill does the projectile land? So they're asking you for the final x and y coordinates. Okay? All right, so we already have our coordinate system. What is the first thing we do? We write our initial velocity in component form. And help me out with A. You? What is A? Hello? What is A? There's A.
Oh, the 0I plus gravity J.
0I minus G. Okay. All right, so that's you set up the problem. Okay. Now we are ready to do the calculation. Okay. Where on hill does the projectile land? Okay, so let's look at the y component of the motion. Okay, again, this guy is 0. So y is v naught y is 65 t minus ay is, oops, ay is 9.8 meters per second, negative 9.8 meters. So that's minus 4.9 t squared. Okay, so the y component of the motion gave us that equation. Let's look at the x component of the motion, x minus x now. X component of the acceleration is 0. So the final x position is v naught x, which is 37.5 t. What is it that we want to find?
The X coordinates on the hill.
Yeah. So we will need to find this, except that they don't give us the time. You have 3 unknowns, x, y, and t, and 2 equations. Sounds like we have a problem. Okay, but it turns out that x and y are related according to this equation. There's the third equation. Okay, so now we should be able to solve it. Okay, so that was the tricky part. So x and y lie on that line, and tan 20 is is 0.36 x minus 109. All right, so there is your third equation, and now you can solve it. Okay. Now, do you guys know how to solve this? Okay, so I'll show you. You'll learn various tricks to solve them, but essentially, so here's something to keep in mind. You already know that if you have n unknowns, to get a solution, how many equations do you need?
N solutions.
N equations. Okay, so in our case, 3 equations and 3 unknowns. All the tricks you learn will be about reducing it to 2 equations and 2 unknowns, and then 1 equation and 1 unknown. Okay, so that's what you want to do. Okay. So again, you just learn these little tricks as you go along. Okay, so they say y and x are related like that. So for y, we'll put this stuff there. For x, we'll put this stuff there. And you'll get 1 unknown and 1 equation. T will be the unknown. So you'll solve for t first, and then you can solve for x and y. Okay? So y is 65. So, all right, so let me, I'll copy this whole thing. All right, so what we have is 65t minus 4.9 t square equal to 0.36 37.5 t minus 109. Did you guys understand what I did? Okay, so now we've reduced it to one equation and one unknown. Okay, and now I know how to solve that. Okay, so that's the deal. All right, so this is a quadratic equation. I'm going to bring that to the right, okay? And this is 13.5 minus that is minus 51.5t. Okay, so there is your quadratic equation. And so t equal to minus b, which is 51.5 plus or minus b square minus 4ac Okay, so what's your solution?
12.3.
12.3. Yeah. Okay, so at this time, where is the object? It's at a location where x and y are related like that. This is where it was at t equal to 0. Okay, so the negative solution has this interesting interpretation. If you go back there, if that is 0 seconds at 1.8 seconds, at minus 1.8 seconds, that's where it was. Okay, had you thrown it from there, it would have gone on that trajectory at the appropriate velocity. So that's what that negative solution means. But this is our solution, okay? Are we done? Okay,
We still need to solve for x and y.
that's right. Okay, so what we want really is the final x and y position. Okay, now we'll put that t in these equations and solve for x and y. Okay, so x is 37.5 t. T was 12.3 seconds. Okay. So the location is 461.3 I plus 50. Okay, that's the location. And here's a check on it. Okay, so you see the x coordinate. Oops. It's 461 meters. So let's see, does that make sense? So in your diagram, this was 300 meters. And that has to be greater than 300 meters, the x location. Okay? And this is positive. Okay? So if you want as a double check, how could you double check that if your answer is correct? Can you think of a way to do it?
Plug in your y position to solve for t.
Okay, so here's another cross check. That is 58.2. And this is 161 meters. And calculate the tan inverse of that and see if it works out to be tan 20. Did you guys understand that? Okay. So what I'm showing you is just little tricks to check and see your work, okay? I mean, you don't have to do it now, but later when you do more complicated calculations, you'll need to learn stuff like that, okay? All right. So again, I want you guys to go beyond just getting an answer. You want to understand what the answer means? Okay. You need to learn little tricks to check and see if you've done your work right and all that kind of stuff. Okay. So you got to go past all of that. All right, I'll do two more problems. So this is a relative motion problem. Let's see, do I want to do this one and this one? All right, we'll do this one, okay? So a river is moving east at 4 meters per second. A boat starts from the dock heading 30 degrees north or west at 7 meters per second. If the river is 1,800 meters wide, this is a little more than a mile. 1,600 meters is a mile. Okay, so from here to the airport, that's a wide river. What is the velocity of the boat with respect to Earth, and how long does it take the boat to cross the river? Okay, so let's do a diagram. The river is flowing. So the velocity of the water with respect to ground, and again, and in this, whenever you're doing velocities, you want to write it in component form. So what is the velocity of the river in component form?
4i plus 0j.
Very good. 4i plus 0j. Okay? So you guys should be able to do that right away. Okay? The boat velocity, this is the velocity of the boat with respect to the water. Okay? And that's 7 meters per second, and that's 30 degrees north or west. Okay, so let's do the components. Velocity of the boat with respect to water is minus 7 cosine 30I plus 7 sine 30j. You guys understand? All right, so we are still just setting up the problem. Yeah. Okay, so now we have the velocities. What is it that we want? So you're starting here and you want to cross over there, okay? What you want is the velocity of the boat with respect to the ground, okay? So velocity of the boat with respect to the ground. Remember, you can insert a letter in between, is the velocity of the boat with respect to the water plus velocity of the water with respect to the ground. And this makes sense. This is the direction of the boat, this is the velocity of the boat, and there's the velocity of the water. The water is carrying it along, so this vector plus this vector gives you the net velocity. Okay? So this velocity of the boat with respect to water plus velocity of water with respect to the ground gives you the velocity of the boat with respect to the ground. Okay? Pilots have to do this all the time. Why do they have to do this all the time?
Earth spin.
Wind velocity, okay? So you go up there, the wind is blowing at 50, 100 miles an hour. You get caught up in a jet stream, that's going at 200 miles an hour. The velocity of the plane is 600 miles an hour. So it can be as big as 30% of your velocity. All right. So velocity of the boat with respect to the ground is those two vectors, minus 6.06 I plus 3.5 J plus 4 I plus 0 J. Okay, so now let's look at this part B carefully. How long does it take the boat to cross the river? Okay, so the boat has a negative x component of velocity, meaning this vector is pointing that way. So it's still going in that direction. So as time goes, the boat is traveling in this direction, but this velocity is just making it go upstream. It's not making it cross the river. This velocity is what is making it, this component is what's making it cross the river. Okay? So we'll look at the y motion. Do you guys understand that? All right, so let's look at the y motion, because the crossing of the river is happening in the y direction. Okay, is the boat accelerating?
No.
No. Okay, so the final y location is what?
1800.
1800 meters. And v naught y is 3.5 meters per second. So about 8 minutes later. Okay. Do you guys understand this? Okay, so again, the addition of velocity, uh, watch this, velocity of boat with respect to ground is equal to, so what did I do? I inserted W in between those two letters. Velocity of boat with respect to the ground is velocity of boat with respect to water plus velocity of water with respect to ground. Okay? So that's how you do addition of velocities. So for the plane problem, velocity of the plane with respect to the ground will be velocity of plane with respect to air and velocity of air with respect to the ground. All right, so that's how you do those. I'll be back in a second for this problem. Just want to show you something. All right, so this problem says a geosynchronous satellite. Do you guys know what a geosynchronous satellite is?
It maintains its position relative to the Earth at all times.
Yep, okay. And so what kind of orbit does it have?
Circular.
Right. All right, so geosynchronous orbit is like this, okay? So the Earth is spinning like that. How long does it take the Earth to spin once? 24 hours, okay? So it turns out that if you guys know the radius of the Earth? 6,400 kilometers, okay? And if you're, let's say 6,000 kilometers, and if you're 6 times further, if you're 36,000 kilometers above the Earth, okay? And if you go in a circular orbit, it takes 24 hours. So 36,000 kilometers above the Earth takes 24 hours. How much does it take now? 24 hours. How many orbits are there with an orbital period of infinite? This one is a geosynchronous orbit. If you're just going in the same direction as the Earth. And you have to be right above the equator. Okay? Why is that so important? Hmm? I'm sorry? Everything has a fixed path.
The Earth isn't perfectly spherical, so gravity would be slightly different.
Hmm?
What was the question again?
Why is it so important?
So that we know that our
exactly where it is. He can bounce off TV signals and charge everybody $100 a month. That is the most expensive parking spot on earth. Okay, there's one spot every half a degree. Okay, so there's 720 spots, and they're assigned to various countries. Okay. And of course, Mr. Elon Musk can park your satellite up there with the Falcon Heavy. Yeah. There. See? There are all those satellites parked there. All right, so now you know what a geosynchronous satellite, and geosynchronous meaning it's synchronized with the Earth's rotation. Okay. Earth at a distance of 42,250 kilometers, that's from the center of the Earth, and you subtract 6,000 kilometers, that's 36,000 from the surface of the Earth. Has a period of 1 day. What is the centripetal acceleration of the satellite? All right, so there's a couple of things going on. So it's going in a circular orbit. It's going at constant speed. Why is the satellite accelerating? I'm sorry?
Gravity's changing direction.
Changing directions. Thank you. All right, and the magnitude of the centripetal acceleration is v squared by r, where r is the radius of the orbit. And remember, to make anything accelerate, you need that kind of force, and that force is coming from the gravitational force of the Earth. Okay. All right. So the speed of the satellite is 2 pi r over the period. Okay. So the centripetal acceleration is 2 pi r over period square divided by r. Okay, so it's an acceleration as units of meters per second squared. Okay. The radius is 42,000 kilometers. Kilometer is 10 to the power 3, so 42.25 into 10 to the 6 meters. And the period is, what is the period? 24 hours. And each hour is 3,600 seconds. Okay. So that. All right, that's, we'll make that 3.6 times 10 to the power 3. That gets squared. That'll kill that. So the centripetal acceleration is 4 pi squared into 42.25. I'll do it on the next page. So what is it that makes this satellite accelerate? What's gravity? Earth's gravity. What is the acceleration due to Earth's gravity? I'm sorry?
You guys can like what the number is?
Yeah, what is the number? You be,
9.8 meters per second.
look at this. What happened? So you will learn as you go. The 9.8 acceleration due to gravity, that's near the surface. As you go further and further up, the acceleration due to gravity, the magnitude decreases. Okay? At that elevation, it's 0.22 meters per second squared. Okay? All right, guys. So we will